Hi, everybody. So the rest of these videos for the first one are going to be shorter. That adding and subtracting, multiplying, dividing. There were so many different ways to do it, so many different types of problems. So I just wanted to share it. We've made it on to 1B, order of operations. You'll see that in the delta math length, this is going to be shorter, but it should be really useful. So we are still in, um, we're still in this first idea. And I've added stuff to this. It's just supposed to be natural, whole integers and rationals, but I threw in fractions and things like that and some other pieces and decimals. Why? Because I think it's really hard to talk about addition without and multiplication without talking about fractions. So that's why these are very long and front heavy, but I think they're gonna be really useful to you. So those were all the adding subtractions, multiplying, dividing, and now we get to go to operations. All the rest of these are way shorter. I put a ton into F because I'm going to talk about percents for a long time. That's one of the most common problems you're going to see is going to be the percents. So we made it to B, which is strategies for properties for operations. And we're going to get into it. So here we go. Let's check out the delta math for this one. As soon as this wants to actually be my friend, I think I'll be good. All right, so if you go here, create edit. Sorry, we want to edit. So here's 1B, properties of operations. Notice, I actually have to edit it so we can see them all. So much less skills, right? They're all going to be way shorter. So operations. This to me is PEMDAS. You're going to get tons of PEMDAS ones for this. I guess we got to reload the page. So you're going to get PEMDAS for this. You got to know that it's parentheses, exponents, multiplication, division, adding, subtraction. A lot of people like grouping in the beginning for grouping for these, but that's okay. It's whatever makes sense for you. But notice how much shorter these are. These are going to be way shorter. So I'm going to give you, we got some box methods here, but basically we're talking about properties. We're talking about PEMDAS. I guess I didn't put any PEMDAS in here. I thought I did. Oh, okay. I don't have this one here. Oh, because we already did the adding and subtraction for all of these. And I guess we'll do divisibility rules as well. The exponents, since we're talking whole numbers, I don't think we need these yet. When we go into algebra, we'll do those. So I added what? I added two more. Not a big deal. So let's get into it. We're all the way here, instructions. And this is the longest one, but I think it has the most information. I'll make the algebra and the geometry also really long, so you'll get the most out of it. So let's close this. Let's go down, 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 down. So you know exactly where I'm writing. So I'm writing in B. In properties for understanding operations. So let's look at some properties. Let's see what we got. Three properties with numbers. Let's check it out. All right, so here's the first one. The answer below about line 1 and line 2 is shown 3 times 2 times 7 and 3 times 2 times 7. This is called the associative property. So I might as well tell you what all the properties are. So we've got identity, which is you're either going to be adding 0 or multiplying by 1. Either way, you're going to get the same value. This one's called the associative. It basically just means we change groups. It's grouping. then we have the communicative property, like you talk to each other, like you communicate. So basically that's A plus B equals B plus A. I said equals B plus A. That's commutative. It doesn't work for division or subtraction, as you can see. We also need to do. We also need to do a couple more of these, a couple other ones to get there. The other one's distributive property. That is the only ones I really think you need. So A, B plus C is equal to AB plus AC. All right, so this is using the associative property of multiplication. 3 times 2 is 6, 6 times 7 is 42. Oh, sorry, 3 times 2 equals the 6, times 7 equals 42. And this is 14 times 3 also equals 42. We did it. Sweet. If you want to see another one, one way, then the way back. This is communicative of multiplication. 2 times 6 is, which equals 12. I don't know what they want in the middle. Oh, I guess it's 6 plus 6. And then this one is 2 plus 2 plus 2 plus 2 plus 2 plus 2, which also equals 12. We did it. And these are just the properties. So try them yourself. This one is also commutative, but this is of addition. Line 1 says 3 plus 6, which is 9 dots. And line 2 says 6 plus 3, which is also 9 dots. And those are the properties, right? Nothing too crazy about it. I don't know why it dropped down so much. I guess there's just so much in this file already, but that's okay. I'm just gonna make it not bold for you. All right. That was the first one. Nothing crazy here. All right, let's keep going. So here's properties level 1. This is definitely distribution property of multiplication over addition, 2x. Ta-da. Might as well see another one. This is the division property of equality. That's what we're doing here. And let's do one more. To get from here to here, we multiplied by 4. So multiplicative property of equality. We go one way, we go the other way. We're talking communication. All right, so hopefully these were easy. Let's try level 2. Ooh, that one looks crazy. All right, 1 plus 2 plus 3 is this. Okay, so this is addition. So communicative property of addition. I believe this is what we did. Nice. So let's try another crazy one. Plus 3. Oh, we subtracted. Nice. So let's do an order of operations. Oh, we got a timed one. All right. So simplify the expression. -3 squared, that's 9, so that's 17. 4 minus 6 is -2, so that's +4. 4 divided by -8, that's a -5. -5 squared is +25 with a minus in front. Wow, that was crazy. -7, +49, -49. This is a -6 squared, +36. 3 minus 6 is -3 times 9 is a -63 minus negative. Oh, sorry, 3 minus 6 is -3. 9 times -3 is a -27, so it's -34. This is a -4 squared, +16. And this is +1. And then we have to multiply this. So that's going to be -32 plus 1 is -31. And the last one is -8, +64, -64. We did it. Beat the best time. All right, let's go back. Let's do simple operations. Okay, so obviously these should be in different order. So that's a +1, +2. Anything divided by 0 is undefined. This is going to be a -7. This is 6. This is anything to the 0 power is 1. Anything to the 0 power is 1. This is -8. Anything to the 0 power is 1. Anything to the first power is itself. Boom. Cool. So that's how you do those operations. I'll write them out for you. This one should go before this one. All right, let's go to this. So right here, what's other stuff we need for this one? If we have 5 divided by 0, that's undefined. Anything times itself. I mean, times 1 is itself. What other things did they give us? They also had 6 to the 0 power. Anything raised to 0 power is 1. Anything raised to the first power is itself. Ooh, if we have a term divided by itself, we get 1. I think those were the rules they asked us to do. All right, let's keep on trucking. Oh, and if it's a negative squared, it becomes positive. If it's a negative squared, but there's a minus on the outside, it also becomes negative. Drag the like terms onto each other. All right, do we have x's? Yeah, match. All right, so the result of this is -9x, combining some like terms. All right, let's do the y's. I tried to drag it over there. There we go. A -6 and a +4 is a -2y. All right, we have this one and this one, which is going to be -3. I think that's everything. We combined all the like terms. Yay, the squareds go together, the x's and the y's and the numbers go together. Ta-da! All right, so here's one that's not guided for us. Let's combine some like terms. A 5x squared, a 5x squared, that's 10x squared, minus 6x squared. That's so we're starting with a 4x. I gotta square it. There we go. All right, so that knocks out those guys. Then when you click the right key, it goes away. All right, those go away. Then I have the -7y. Then I have a 3, a 5, which is an 8, and 8 minus 1, 8 minus 7 is going to be a +1. That's the answer. Now, if you have this for a student, this way looks beautiful. I would always show them what this actually looks like, you know? So don't be afraid to let Desmo's calculator be your friend and actually show your students. Whoa, sorry, I believe it was 4x squared minus 7y plus 1. Okay. So we got a 4x squared minus 7y plus 1. We gotta have to make it equal to something. There's the parabola. Beautiful. X squared will always give us this happy face shape. And when it's even, both arms will always go up. Touchdown. All right, let's keep on trucking. Here's our distributive property. I'll write this one out. So we have -2x, 9x minus 7, multiply, -18x plus, because 2 minuses make a plus, that's a common mistake that happens, 14x, and x times x is actually x squared. That's your answer. So it's -18x squared plus 14x. And going backwards, that's factoring it because they both have a 2 in common and they both have an x in common. And there it is. Woo! I'm gonna show the other side. Ah, I love the animations. All right, let's do the next one. Let's do a harder one. All right, here we go. It looks almost exactly the same. I'll put it next to it. So we have 10x 10x squared minus 3. Well, 10 times 10 is 100. This is x to the 1 times x squared, so that means we have 1, 2, 3 x's. We have times it by this, it's minus. 3 times 10 is 30, negative 30, and it has no x, so there it is. And here's your final answer, which is 100x to the third power minus 30x. Ta-da! Well, they didn't show the fancy little notes here, but I'll survive. All right, so now we get to add, subtract some polynomials. Why'd I put these in? I just think they're going to be useful for your students to know. So if I have 5x squared plus 10x plus 6, and we want to add, notice how I'm matching them. So if I put these all together, I get a positive 4, I get 20x, and I get 15x squared. The friends match. The friends match, things like that. You can show it with different colors, students like that. So this is 15x squared plus 20x plus 4. Magic. All right, I'll do another one. Maybe they'll give me a subtraction one here. Here we go. I got a subtraction. So might as well drop it down so it's in another one. So here we go. Negative 5x squared plus 4 minus, and here's the big mistake that so many students will make. They don't know that the minus goes to all of them. You can tell them there's like an invisible -1 in the front, or just bring this to everybody. So this changes this sign, and this makes this sign also negative. So it's really going to be negative 5x squared, because we changed the signs. It's now plus positive 10x squared minus 6. So our answers are going to be 5x squared minus 2. And this is going to be a happy face. The 2 means we brought it down. This is a regular happy face. And just so you can, if you ever want to show your students more, the minus 2 means we drop it down 2 places, and the 5 means it's 5 times as skinny. So there's your answer, 5x squared minus 2. Ta-da! And if you want to show them what it looks like, this is what a regular x squared graph looks like. Ta-da! And now if I have x squared again, right? When I do minus 2, what happens? It falls, and if I put the 5 in the front, it gets 5 times skinnier. Ta-da! Cool. All right, let's keep on trucking. We are flying through them. All right, so now we got box method. Okay, this stuff happens all the time. 4 times 5 is 20. X times x is x squared. 4 times 2 is this. So we just need the missing term. So what is 1 times 5x? It's 5x. This box method they use all the time. So we have a 4x and times a 5x, so this is a 20x squared. Ta-da! So it just is a different way to show multiplication. They always show it this way with the properties. All right, so here we go. We get a full one. Oh, we get to drag it. All right, so let's move the 3x here, the minus 6 here, the 3x here, the positive 2 here. Now I get to multiply 9x. I need to put a squared here. Do I just put another x here? Nice. If I hit shift 6, it brings it up. This is 6x. This is negative 18x. Because negative 6 times 3x. And finally, negative 12. Now we simplify it. So 9x squared. 6 and 18, that's negative 12x minus 12. We did it. We did it. Cool. So use the box method to distribute. We need, I believe, 2 rows and 1, 2, 3, 4, 5 columns. Insane. Okay. Let's go with the dragging. I'm gonna put this in order. I don't like that it wasn't in order, so I'm gonna order it. Cool. 12x to the 5th. 12x to the 4th. Negative 36 x to the 3rd. 6 because there's an imaginary 1 in the front, so 6x squared. Negative 12x. Then we got to do all the bottom ones. So this is negative 6x to the 4th. Negative 6x to the 3rd. Positive 18x squared. Negative 3x. And positive 6. Sweet. Oh, all the simplification. All right, 12x to the 5th. There's only one like that, and I have 2 of these, so it's going to be plus 6x to the 4th. And now it's going to be 2 of these, so minus, that's 42x to the 3rd. Plus 12x squared. Minus 15x. That was a lot. If I missed a piece, that's okay, but I think that's the answer. And you can show a student what this looks like. This is a crazy polynomial. All you have, your answer is not correct. All you have to do now is add up the like terms. I missed one. 12, positive 6, negative 42. That's right. Positive 12. Oh, there it is. Positive 24. Thanks for telling me. My bad. Made one little mistake, but you can take this thing and show your students what it looks like. Oh, I hate that doesn't give you the full piece, but I'm just going to reload the page. If I have 5x to the 5th power, you can't really see it, but it's jumping all crazy. Minus 3x to the 4th, whatever it was. Minus 2x plus 7. It's really looking like an x squared and not this. Is it because I don't have a, if I make this positive, 2x to the 3rd? I don't know. All right, well, it should bounce a couple more times, but it's okay. It's okay. All right, let's do the next one. All right, so I did 3 before I did 2. That's okay. Let's see what this one has in store for us. This is the same thing, just in other columns. I'm not gonna make you do number 3. I think it's too much, so we're getting rid of that guy. All right, let's go to rounding. Who's excited? I'm excited. So round to the nearest 100. So that's the 10th place. That's the 100th place. So it's just going to be 9.40. Let's do a couple more of these. I like it. To the nearest 10th. There's the 10th. So it's 4.4. Whoa, 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 whoa. Why did it look all weird? All right. So the nearest whole number is 0. Because it's more here, there's the midpoint is 5. Great rounding. Let's do one more to the nearest 100th. So that's here. So it's 5.06. Ta-da! Cool. All right. So here we go. Here's another good way to round. So plot -3, 4, and 4 on the number line. So clicked. So here's -1, 2, 3, and here's 4 on the number line. Find the distance. 1, 2, 3, 4, 5, 6, 7. I'm going with 7 units. We did it. Let's do one more. All right. Here we go. -1 is here. 12 is here. And what's the distance? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We got 13 units. Nice. All right, so let's plot and find the distance. Now we have the same thing but decimals. So here's -1.3 is right there. And 6.5, so that's right in between 6 and 7. All right, now let's find the distance. So we know this is going to be 0.3. So that's 0.3, 1.3, 2.3, 3.3, 4.3, 5.3, 6.3, 7.3, but then I got to add it half. So 7.3 plus 0.5 is 7.8. So if you want an easier way to do it, you'd always think about it this way. This is how I think about it. I was like, I've got a -1.3 minus 6.5, and I need the absolute value. So subtracting two minuses, like adding them together. So this is like basically 1 and 6 is 7, 3 and 5 is 8. The absolute value of this is 7.8. That's how I visualize it. Or the number line works too. All right. Woo, here we go. Some crazy stuff happening right here. So we've got division and multiplication. So let's see. Let me move my weird head and let's get after it. -1/16 divided by 1/20 times 12/7. All right, so I'm gonna basically, to do this problem, I'm gonna do this chunk first. So I'm gonna do -1/16 and I'm gonna multiply the reciprocal. So it's gonna be times 20/1. Now these we can simplify. We can divide them both by 4. So this is really going to be a 4 and a 5. So it's -5, because -1 times 5 is -5 over 4 times 12/7. And I just bring down the other guy. These we can cancel. 4 goes into 12 3 times. Your final answer is -15/7. They want a fraction in simplest form. That's what I'm going to give them. Beautiful, beautiful. They multiplied by the reciprocal. They simplified. Perfect. They multiplied. Oh, I simplified first. So they simplified at the end. I simplified at the beginning, so I would do less mental math. All right. Getting harder. Getting harder. All right, let's see what we got. Mixed operation with rational numbers. So if this is hard for you, try some. So it's 0.4 on top. Then I'm basically going to do this first. 2/9 plus 4/9. I can add these, right? So it's going to be 0.4 divided by 6/9. So I'm doing 4 divided by 6/9, and it's 0.4. So if I have 0.4, let's think about this is fractions. Let's make them all fractions. So this is 4 out of 10's place. So it's 4/10 divided by 6/9. So what's the opposite of dividing? I can multiply by the reciprocal. So multiply this by 9/6. Cancel, cancel. Multiply this by 9/6. 4 times 9 is 36. 10 times 6 is 60. We could have canceled here, but they always wait to the end, so I'm trying to do it like them. I could divide both of these by 6. So 36 divided by 6 is 6. 60 divided by 6 is 10. Oh, we can go further. Divide it by 2. And our final answer is going to be 3/5. Let's see if I did all that math right. So you try it yourself. Beautiful, beautiful. They did the same thing I did, but they simplified here. Oh, they did a different way. Okay, they made the 6/9 2/3 first. So before they simplified at the end, and here they simplified at the beginning. Can't win. All right, three more to try. This is level 3. Let's see how hard this one's gonna be. Woo! All right, so this is probably the hardest one we're gonna get for these. So let's see if I can pull it off. 4.5 plus 6 4/5 minus a minus 2.5 plus 6.8. Wow, what a crazy problem. All right, so let's see what we can do. I'm just going to do this piece first. So multiply the bottom, add the top. 8 plus 1, that's 9/2. Multiply the bottom, add the top. 34/5. Now I can't add these until they're the same, so I'm going to multiply this by 5. So this is 45/10. Multiply this by 2, and we've got 60. Oh, I lied. 68/10. 2 times 4 is 8. 2 times 3 is 6. We add these together. 45 plus 68. We get 113/10. All right. Now, why is this good? These are all in tenths. There's a 10th place. There's a 10th place. So I can make them all decimals. Or I'm sure you guys hate fractions like most of my students. So you can make this 2.5 tenths. You can make it 2 5 tenths. Or you can make this what? 25 tenths. We can make this what? 68 tenths. So this is the way my brain would do it. 113, 2 minuses make a plus. So 113 plus 25 tenths plus 68 tenths. What's the other way? Divided by 10, we get 11.3. So the other way of seeing this is 11.3 plus 2.5 plus 6.8. Any way you're going to get the right answer. So I'll add the 2.5 first. So there's an 8. There's 13.8, right? That's 13.8 plus 6.8 is, well, 0.8 and 0.8 is 6, carry the 1. 3 and 6 is 9, plus 1 is 10. So I have 20.6, so it's 20 6 tenths, or 20 3/5. That's one way to do it. Now, if I add these fractions together, you'll see it's the same thing. 113 plus 25 plus 68. 8 and 8, that's 16, carry the 1. 6, that's 9, 10, carry the 1. Boom. 206/10. Either way, we have the same exact answer. What are we going to be left with? 2 6 tenths. Sorry, 20, right? And 6 tenths. We divide it, 20 6 tenths, or 20 3/5. That's as crazy as it gets. 20 3/5. Oh, and we could do a decimal. Nice. I did it right. Where's the decimal? 20.6. And that's what we had over here. There's our 20.6. So either way, we get the right answer. All right, there's like 2 more to go. Oh, 3 more. I'm a big liar. Oh, it's because I added some. So when written as a simplified polynomial in standard form, we have 3x minus 2 squared. It's subtracted. All right, so this one's probably too hard for you to do, but that's okay. 3x minus 2 squared. So what does this really mean? Then we have to subtract that from, we have to subtract this from 9x squared plus 4, but we can't yet. So anytime you're squaring something, you might just think, oh, I just do this. You don't. This is the most common mistake I always see for algebra. So 3x minus 2 times 3x minus 2, we get 9x squared. You miss the middle pieces if you just go that way. Because it's like a square with 3x minus 2 on one side, 3x. That's the way they want you to see it. So this is going to be a negative 6x. Then we go this way. I do double rainbow, minus 6x, and then plus 4. So it's really 9x squared minus 12x plus 4. And we're subtracting this from 9x squared plus 4. 9x squared plus 4. Now this whole thing is being subtracted from this. So we have to distribute the minus sign. So this minus sign's got to go here. So you're a minus here. You're a plus here. You're a minus. So a 9x squared and a negative 9x squared drop. We have a positive 12x. We should always go in order. And it's a plus 4 and a minus 4, which drop. So our answer is just 12x. That was a lot of work. Get the right answer. Oh, what? 9x squared plus 4x minus 9x squared minus 12x plus 4. So it's minus 9x squared plus 12x. But it was a positive 4, so it turned minus 4x. Oh, when I rewrote the problem, I forgot the x here. I forgot the x here. All right, well, I guess I could do it one more time. One stupid mistake. That's okay. It happens. Whoa, craziness. All right, let's do this one. So the first step is 3x minus 8 times 3x minus 8. I can't believe I just forgot this one little number. That was an x and not a whole number, like in this one. 9x squared, negative 24x, negative 24x, positive 64. So I've got a 9x squared minus, minus 48x plus 64. Now this whole thing is being subtracted from this other piece. So it's 5x squared minus 10. And then it's minus 9x squared minus 48x plus 64. Now, this whole thing has to be subtracted. So this is why the signs change. This minus has to go to all of them. So it's 5x squared minus 10 minus 9x squared plus 48x, because the first one was negative, right? Yeah. And then it's going to be minus 64. We have to combine our like terms, so 5x and a negative, so it's negative 4x squared plus 48 minus 74. Not forgetting you this time. Crazy problem. Yeah, I'm sure. All right, well, I'm just clicking the solution. Oh, I gotta reload the page. It froze on us. Negative 4x squared. Yeah, we got it. All right. The last two don't want to exist. That's fine. We're going to edit assignments. We're here in 1B. I want to edit this. Go to skills. And we are. Was that the last one? Oh, that was the last one. Oh, that's why. Okay, so we did them all. Hopefully that was useful. That was some extra stuff thrown in there just to help, but this was knowing the properties. So I would remember identity, associative, commutative, and distributive. Those are the main things you got to know. This one's grouping, this one's back and forth, this one distributes. Identity, you either add 0 for addition, multiply by 1. That's like 6 plus 0 equals 6. And 6 times 1 equals 6. All right, I hope that was useful and enjoy your day.